Number 5. Consider a function fx equal to 1 over x minus 4 plus 2. Question A. Simplify fx in the form of p of x over q of x when the q of x not equal to 0. Based on the function given, fx equal to 1 over x minus 4 plus 2, we need to make their denominators same. So, 2 need to multiply with x minus 4 over x minus 4. Then it will be 1 plus 2x minus 8 over x minus 4. 2 minus 8, it will be 7. Then the answer will be 2x minus 7 over x minus 4.
So I'm going to explain on how to answer question B, which is find the vertical asymptotes and horizontal asymptotes and its analysis. For vertical asymptotes, we have to let the denominator that was given in the question equals to 0. So let x minus 4 equals to 0 and you arrange the number and we will get x equals to 4. Next, we have to analyze the vertical asymptotes by approaching the values from left and right hand sides. For left hand side limit, x approaches 4 to x minus 7 over x minus 4, and by direct substitution, the final answer will be infinity. Do not forget to put negative sign in the answer because we use the left hand side limits. Apply the same techniques for right hand side limits. Limit x approaches 4 to x minus 7 over x minus 4, and the answer will be positive infinity. Next, for the horizontal asymptotes, we have to find the limit of fx when x approaches infinity by dividing numerator and denominator with the highest degree of x in denominator. So limit approaches infinity to x minus 7 over x minus 4 divides by the highest degree of the denominator, which is x. After that, we have to substitute x by infinity. And remember that every number involved with infinity sign will turn into 0. So we will get 2 minus 0 over 1 minus 0, and the final answer will be 2. Do not forget to write x equal to 4 for vertical asymptotes and y equals to 2 for horizontal asymptotes in order to emphasize the final answer.
We move to question C is find the interval where fx is decreasing. So we know that our equation is fx equal to 2x minus 7 divided by x minus 4. So step first, we have to find the first derivative is f prime x. So one way to find the first derivative, we use v u prime minus u v prime divided by v squared. Okay, so how we want to know the what's value of v, u prime, u and v prime. So from our equation, we know that above division is u and the below is v. Right here, u equal to 2x minus 7 and v equal to x minus 4. We want to find u prime and v prime. We just differentiation u and v. First we differentiation u, and here we get 2 and here 0. So the answer u prime equal to 2. And next we differentiation v, and here we get 1 and 0. V prime equal to 1. All the value here, so we just put into the formula. Get f prime x equal to minus 1 divided by x minus 4 squared. And step second, we to let f prime x equal to 0. So we take the below to here. So minus 1 divided by x minus 4 square equal to 0. So actually here we have cross multiply. So here is we get minus 1 equal to 0. So this is false, not equal to 0, right? The denominator part right here, x minus 4 square equal to 0. So here we have square root. That's why we will get x minus 4 equal to 0 and value of x equal to 4. And step 3, we do the first derivative table, minus infinity 4 and 4 infinity. So for test value, it's any value from the minus infinity until the 4. So between here, we can just take as test value. Okay, so I take value of 2, and here is 4 until the infinity, so we can take any value from here, and I just take C as test value here into the f prime x minus 1 over 4. So just write the symbol of positive negative here, and when we substitute 6 into the x, we will get minus 1 over 4. Just write the symbol negative. This both is decreasing, and we write that here. And increasing interval, we did have nonce, so we just write nonce. And decreasing interval, we will write negative infinity 4. Don't forget to write union here, and for infinity.
Next, in question D, we are going to find the intervals whether the fx is concave up or concave down. First, we are going to find the second derivative of f second derivative x. First, we need to simplify the f prime x equation, which is negative 1 per x minus 4 with the power of 2. Then we are going to bring the equation of x minus 4 to the up to make the equation more simplified. The equation then will become negative 1 multiply x minus 4 with the power of negative 2. After that, we're going to find the second derivative by making the equation 2 with the open bracket x minus 4 with the power of negative 3, and then multiply it again with 1. The equation then will become 2 open bracket x minus 4 with the power of negative 3. Then to make the power of negative 3 positive again, we are going to bring the x minus 4 to the down to become per. Then the equation will become 2 per x minus 4 with the power of 3. After that, we are going to let the f second derivative x equals to 0. Then we are going to notice that 2 per x minus 4 with the power of 3 equals to 0 will be no such x value. We're going to notice that f second derivative x is undefined when the equation will become x minus 4 with the power of 3 equals 0. Then we are going to bring the positive 3 to the back and make the equation x minus 4 equals 0, and then make the 4 positive by bringing it back to the become x equals to 4. Now we are going to make the second derivative table, which has 3 columns. In the first column, we are going to represent it with interval, test value, and sign of f second derivative x equals to 2 per x minus 4 with the power of 3. In the second column, we're going to represent it with the coordinate of negative infinity to 4 with the test value of 2, which is going to become negative. And then in the third column, we're going to represent the coordinate with 4 to infinity. With the test value, we're going to put 6 with the test sign going to be positive. From the table, we know that the concave up is going to become coordinate 4 to infinity, and concave down is going to become negative infinity to 4.